Drills are the most commonly used tools for creating holes. Short spotting drills are used to create shallow, conical holes, preventing longer drills from wandering off center. Frequent retracting, known as peck drilling, helps clear chips. Screw machine drills are much shorter and can drill straight, accurate holes without spotting. Programming a CNC machine to drill holes is simplified with the use of canned cycles. The table and spindle initially traverse to the starting position of the first hole. The G81 command, followed by various parameters, initiates the can cycle. G81 is a modal command, meaning it stays active until another command cancels it. Drilling additional holes only requires specifying new coordinates. Drilling into an angled surface requires spot facing using the center cutting end mill. After spot facing, a standard drill can be used. Chucking reamers are used to enlarge pre-drilled holes to very precise diameters. Slow speeds as well as coolant or lubricant should be used. Power tapping is a fast way to tap holes on a conventional machine equipped with a quill and a 3-phase instant reversing motor. Synchronized rigid tapping on a CNC machine is accomplished using the G84 can cycle. Helical boring with an end mill is an economical way of creating larger holes. Deeper holes can be made using a boring head. The adjustable twin cutter unit shown here is used to enlarge pre-drilled holes. A finish boring head holds a single adjustable cutting edge for the highest precision and the smoothest finish. milling machine is a machine tool with a rotating cutter, typically used to shape, slot, and drill solid metal workpieces. Most machines have 3 axes of movement, X, Y, and Z, the same as those of the Cartesian coordinate system. On a manually operated conventional milling machine, the milling table can be moved side to side along the X-axis using one of 2 hand wheels. The table sits on a structure called the saddle, and together can be moved transversely along the Y-axis. The spindle, which holds and rotates the cutting tool, is housed in the milling head and can be moved vertically along the Z-axis. Z-axis movement can be accomplished by moving the entire head vertically along the column. Alternatively, the lever-operated quill can provide rapid vertical movement for operations such as drilling. A vertical machining center, or VMC, is a computer-controlled CNC milling machine. Movements are very similar to those of conventional milling machines, with the table moving along the X-axis, the Y-axis, and the spindle head moving vertically along the Z-axis. Machine structures such as the table, saddle, and milling head slide along a set of rails. Some machines use linear motion guides, which are low in friction through the use of circulating ball or roller bearings. Other machines use cast iron box ways, which can be more rigid at the expense of added friction. Hand wheels are used to apply power for axis movement on manual machines. Highly accurate servo motors are used to apply power on automated CNC machines. Lead screws, such as the Acme screw on this conventional machine, translates rotational movement into linear motion. CNC machines use ball screws and ball nuts. Ball bearings which circulate within the ball nuts reduce friction while increasing accuracy.